Okay, we're going to go over the review for chapter one test. It's going to be broken down into two videos. So I'm going to use the one from the textbook. It's the same questions. Some of them might be slightly different because of how they're asked on the computer. They might be like multiple choice or multiple answer or select all to apply, things like that. Whereas the ones on the actual textbook pages are more like free response questions for a lot of them. So I'm going to go through each question. Again, it'll be broken down into two parts. So starting with section 1.1, let me blow this up a little bit. All right, so too big. So for the first question, give another name for plane M. So there's lots of different ways that we can name a plane. They use the M that's in the corner. We are going to use points now instead. So you can use any 3 points to name a plane. So on this diagram, you have points X, Y, Z, and N all in the plane. Well, to name the plane, you need to use at least 3 points, but they also have to be non-collinear points. So we can't use X, Y, and Z together. We're going to have to use N. So we can do any combination. Let's say I said plane N, X, Y, or plane N, Z, Y, or plane N, X, Z. Now, any of those 3 work, plus any combination of those same 3 letters that we use for any of these mixed around. But again, you cannot use X, Y, and Z together because they are in a straight line. Then name a line in plane M. Well, there's only one line in plane M. So for that one, you have line G would be the first most obvious choice here. So we have G at the end of the line that appears on this plane. So you could just call it line G. Now, the other options, we have 3 points on the line. It takes 2 points to name a line. So we could call this line XY. And do my correct notation there. Line YZ, again, doing my correct notation. And line XZ, again, using my correct notation. Then it says name a line intersecting plane M. Well, there's only one line intersecting plane M. That's line H up here. So again, we can either call it line H, or we can use the 2 points there on the line and call it line PY. Or again, you can reverse that as well. But again, make sure we use proper notation. Name 2 rays. Again, it could be any 2 rays in this figure. It didn't have to be any specific rays. It didn't say it had to be on the plane. So any 2 rays. We could do, for line G, there's a couple points there. We could have called it X, Y, or we could go on the other way, Y, X. Again, those are 2 different rays. Or if we use this other line, we had P and Y on there. We have P, Y, or we could have done Y, P. We could have done, you also use point Z if we wanted to do ZY or ZX or XZ or YZ. Those would also work. So there's lots of combinations possible. On number 5, name a pair of opposite rays. Well, the only points we can use for the opposite rays are these 3, because in order to have opposite rays form a line. They also have a common endpoint. The common endpoint here is Y. So if we have Y, we can go one direction and go to X, and the other direction can go to Z. So the 2 opposite rays are going to be YX and YZ. Name a point not in the plane. Well, there's only one point not in the plane, and that's the one way up there at the top. That's point P. And then finally, number 7, is it possible for the intersection of 2 planes to be a segment, line, ray? Sketch the possible situation. So this one was tricky because the correct answer is only going to be a line. A plane extends infinitely in all directions. So if I was to sketch this, let's say I draw a plane kind of like vertically here. So something like that. And then I draw another plane going horizontally through this. I'm going to draw this as a dash line, and then the intersection is going to be this line right here. Now you notice I'm extending it past where I drew the planes. When I draw a plane, I'm only drawing part of the plane. The plane extends infinitely in all directions. By definition, a plane and a line extend infinitely in all directions. So a plane is a two-dimensional surface extending infinitely in all directions. When two planes intersect, they intersect at lines, not just a segment. So that one's a little bit tricky. All right, let's go ahead and clear this, move it up. Now we're looking at 1.2. Let's see if I can't fit all these on this page. All right, so for the top one, number 8, here they want us to find xz. So here's x, here's z. So we're looking for the overall length of these. So we're just adding those together. 17 plus 24 to give us a total of, what is that? 41. Then we have number 9, the entire length there. We have 38. The length of AX is 27. We just want this length of XZ. So we're going to subtract the difference. 38 minus 27 for a difference of 11. On number 10, plot. Now, you already had them plotted if you did this on the computer. If you didn't do it on the computer, you have to plot them first. So I'm just going to sketch an X and Y axis here. 1, 2, 3, 4. Yeah, that should be over far enough. So I have a point at 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I have a point at 3, -4. 1, 2, 3, -4. I have a point at 7, 1. 7, 1. And at 7, -3. 7, -3. So these are my lines. So I had, this was A, this was B, this was C, and this was D. The length here, since it's a vertical length, I can just count those. That's a total of 4 units. A, B, again, I can count those. That's a total of 5 units. So 5 and 4 does not have the same length, therefore they cannot be congruent again. Congruent segments have the same length. On number 11, 2 parts to this one. First, they want to know what this length is between the school and the library. So we can use these 2 numbers to figure out that length. 654 is the total distance from the home to the library. And then the distance from home to school is 528. So if we just subtract those numbers, so we have 654 minus 528. Let's see, 4 minus 8, that's going to give us 6. I had to borrow 1 there, so this is really now 4. 4 minus 2 is going to be 2, 1, 126, and this is in meters. Now, the second half of this is how long would it take to walk from home to the bookstore. So let me erase part of what I just did. So I'm not using those same pieces. Now I'm going to take this entire length from home all the way to the bookstore. So I'm going to use these 2 values now. These 2 I'm going to add together to figure out the entire length. So I have 782 plus 528. That's going to combine, give me 0 out of 1. That adds up. And carry another 1. This is going to be a total of 13. So I get 1,310. That total length in meters then gets divided by the speed we were walking, 68, to give us a total time of 19 point, I don't remember the number, I think it's like 19.26. I haven't had to use a calculator up until this point. Let me see if I have a calculator right here. So we had 1, 3, 10 divided by 68. Yeah, that's right. 19.26. And that's minutes. So that was 1.2. Let's move on to the next section. Now 1.3. All right, this one. Oh, hopefully that'll focus a little bit there. There it goes. All right. On number 12. So now we're using distance and midpoint formulas. So first, let's write down those two formulas. So our midpoint formula is going to be x1 plus x2 divided by 2. Again, average of the x's. Then y1 plus y2 divided by 2. Average of the y's. This is on our reference sheet. So again, you can use our reference sheet to do that. You also have the other formula that you need to know is our distance formula. So distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. Again, both of those are on our reference sheet. Now, the other one that you could use in place of distance, which is not on the reference sheet, is Pythagorean theorem. C squared equals a squared plus b squared. And for some of these problems, I definitely think it's easier to use Pythagorean theorem. So now, on number 12, first it says, the endpoints of ST are given, find the coordinates of the midpoint, and find the length. So on both these problems, 12 and 13, we're using both formulas. So first, midpoint. For midpoint, we're going to plug in both x values, so -2 and 3. Oops, that should have been plus, not a comma. And then both y values, 4 and 9. Well, -2 and 3 is 1, so that's 1/2. 4 and 9, that's 13. So 13 over 2. That's a good final answer. Again, it's okay to leave your answers as improper fractions like that. You could also simplify them and have 0.5. And for this one, it would have been 6.5. But again, improper fractions is a good way to leave your answer. Then for distance, so we're plugging into distance formula. The x values first, we got -2 plus, sorry, not plus, minus, my bad. Let me get rid of that. -2 minus 3 squared plus 4 minus 9 squared. So -2 and -3, that's going to give us -5. Again, if you're using a calculator to do that, make sure you include those parentheses because you want this next answer to be a positive. Same thing here, this is -5. So if you're plugging that into the calculator, you have to use the parentheses. So now that's 25 and 25. So we get the square root of 25 plus 25, which is the square root of 50. Now I don't know the square root of 50 off the top of my head. So let's go to the calculator. That is roughly 7.07 or 7.1, depending on what we're rounding to. Same thing for the next one, number 13. Use those same two formulas so we can plug in. We have 6 plus 7 over 2 and -3 plus -2 over 2. This gives us, let's see, that's 13 over 2. This side's going to give us -5 over 2. Again, we can leave those just like that. We don't have to simplify them. Improper fractions are fine. They can't be reduced. Now, distance formula on this one. Let me go over here off to this side. So 13, we have distance equals the square root of, we got 6 minus 7 squared. Sorry, sometimes this pen lags out on the computer. Plus -3 minus -2 squared. Well, first, minus negative becomes plus a positive. Then we have square root of 6 minus 7 is -1. -3 plus 2 is also -1. It does not always work out that these parentheses are the same. It just happened that way on these two problems. So that's 1 squared is 1, 1 squared is 1. So that's the square root of 2, which is roughly 1 point, I think 3 or 4. Let's see, square root of 2, 1.41. So that's the other part of 13. Now, on 14, they give us the midpoint, they give us an endpoint. This is where we can do snowman method. All right, so talked about snowman method before. I'm going to build myself a snowman using my parentheses. The midpoint we know, put it in the top. Sorry, that's wrong. Not the midpoint, the endpoint that we know, put it in the top. 14 and 9. The midpoint goes in the middle, 6, 3. Then we need to figure out, all right, what are we adding or subtracting to get to those values? So from 14 to 6, that's a difference of 8. So we went -8. So go -8 again, and we're at -2. For the y values, we want a difference of -6. So do -6 again. 3 minus 6 is -3. So our final answer is -2, -3. On 15, point M is the midpoint of segment AB, where AM, they give us an equation, and MB, find AB. So they're giving us the two halves, and we have to find the whole. Now, it'd be easier if we draw a picture first so that we can see what we're actually doing. So I'm going to actually draw a picture over here. Here's A, here's B, the midpoint in the middle. And then we have 3x plus 8, 6x minus 4. And we're looking for this entire thing. Well, before we can do that, we need to know, all right, these were congruent because that's the midpoint. So we can set them equal. So the equation we're writing is 3x plus 8 equals 6x minus 4. Solve, combine like terms, so bring the 3x over to the other side. 3x subtracted from 6x now is 3x. Bring the 4 over by adding it. That's 12. Divide by 3, and x is 4. Again, we don't stop there. You take x and we plug it in. So plug x in to the equation for either one of those. We should get the same thing since they're supposed to be congruent. But AM is equal to 3 times 4 plus 8. Again, we can check our work by doing both. So MB will be done by doing 6 times 4 minus 4. So on the first one, 4 times 3, that's going to give us 12. 12 plus 8, that gives us 20. On the bottom one, 6 times 4 is 24. 24 minus 4 is also 20. So both halves are 20. So altogether, the entire length will be 40. Now, on 16, the coordinate 3 has a weight of 2, and the coordinate 9 has a weight of 1. Find the weighted average. Again, it's just like doing a regular average. It's just saying that, all right, since we have a coordinate that has a weight of 2, it's like we're doing that one twice. So 3 times 2. 9 has a weight of 1, so 9 times 1. How many weights do we have total? 2 there, 1 here. Our weight is a total of 3. 3 times 2 is 6. 9 times 1 is 9. 6 plus 9 is 15. And 15 divided by 3 is 5. And that's our weighted average. Let's do it again with this one. So a coordinate of 4 has a weight of 1. So 4 times 1 plus 5 has a weight of 3. So 5 times 3. And 11, so plus 11 has a weight of 1. On the bottom, again, we're adding up all our weights. So this time I'm going to show it. So we had the 1, we had 3, and we had the 1. Those are adding together. So our bottom value there is all of our weights. It's 5 total. So what do we have now at this point? Well, again, I said 5 on the bottom. We have 4 times 1 is 4. 5 times 3 is 15. And 11 times 1 is 11. So add those all up. That's going to be 19, 20, 30. So we get 30 over 5, which is 6. All right, on 18. This one, there are several different ways to do. They gave us the information about where the pitcher's plate is. It's 3 feet short of the midpoint. So first thing I'd do is draw on here a triangle so that we can get the total distance from home plate to second plate. Now, these side lengths, it's kind of hard to see here. Use a different color. These are 90 based on those coordinates. So 90 and 90. Now, I don't know this side. I'm going to call it X. But I can use Pythagorean theorem. So C squared equals A squared plus B squared, what I had mentioned earlier at the top here. So X is going in for C. The 90s are going in for A and B. We have 90 squared is going to be 8,100. Add those together, and we get 16,200. And now we need to take a square root. So 16,200, do not know that one off the top of my head. So 16,200 gives us 127.27. Now, and we can take that, divide it in half. Now, I'm leaving the number on my calculator so I have less rounding error. So divide by 2. This is going to give me the distance to the midpoint. So that's 63.63. And then finally, take off 3 from this because it was 3 feet short of the midpoint. So right now, it's currently 63.63 feet from home to the midpoint. We need to subtract off 3, and we end up with 60.6. And actually, if we rounded this correctly, this should have been a 4. Same thing here. This should have been a 4. This, I'm not sure going back that far, but I just realized I did round that a little bit off. They want your final answer. Doesn't say. So roughly 60.6. I'm just going to say 60.6 feet. All right. Let's see if we can't do one more section. So let's clear that off. Let's go to this is now 1.4. Get it right where I want it. Close enough, whatever. All right, so 1.4. Classify polygons by the number of sides, tell whether it's concave or convex. So first figure, all the angles point out, that is convex. Up here at the top of this figure, it's going inwards right here, boom, boom. So this is going to be concave. All it has to do is go in once, and it's considered concave. Now, number of sides. We got 1, 2, 3, 4, 5, 6. 6 sides. That makes this a hexagon. This one, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides makes this an octagon. On 21 and 22, it says find the perimeter of the area of the polygon with the given vertices. So this one, I would recommend sketching these. I think in both cases, they give us triangles. So we have 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Then we have 5 and -1. Then we have, oh no, this first one's definitely not a triangle, sorry. Then we have 2, -1. to -1 right here. The last point, 2, 6. So this one is a rectangle, 2, 6. Let's see if I can't draw a straight line here using my tools. Make this look a little bit better. All right. So now, finding the lengths of the sides is important. 1, 2, 3 units on this side. Going up, we're going from -1 to +6. That's a difference of 7. So 3 and 7, they want area and perimeter. Well, we have 3 and 7 for all the sides here. For area, that's base times height for a rectangle. So we have 3 times 7, which is 21. Again, that'd be in square units. And then our perimeter, we're adding them all up. So 3 plus 3 plus 7 plus 7 gives us 20 units. All right. That's the first one. So 21, that's our work. 22, and do the work on the opposite side. So start off with our X and Y axis again. 6, 1, 2, 3, 4, 5, 6, -2. Then we had 6, 5, 2, 3, 4, 5. Then we have -1, 5. So just like the last one, we have some nice horizontal and vertical lines here. We end up with a triangle this time. So for the 2 dimensions that are horizontal and vertical, we have going from -1 to +6, difference of 7. From 5 to -2, also difference of 7. So we have the 2 legs. We need the hypotenuse here. So you can use distance formula or you can use Pythagorean theorem. I recommend Pythagorean theorem. I'm going to call this x for now. X squared equals 7 squared plus 7 squared. So that's x squared equals, and this is 49. And it's lagging bad. All right, then we have 49 and 49 gives us 98. So I need the square root of 98. Square root of 98. 9.899, so 9.9. So we have all of our sides. If we do area, area is 1/2 base times height for a triangle. Base and height here are both 7. So 7 times 7 is 49. And 49 times 1/2 or divided by 2 is going to give us 24.5. Since that's area, again, units squared. Then we have the perimeter. We have all 3 sides now. So we have 7 plus 7 plus 9.9. 7, 7 is 14. That's going to be 23.9. And that'd be in units. And that's it. So that's 21 and 22. Now, 23. 2 polygons are shown. Compare the area and the perimeter of the concave polygon with the area of the perimeter of the convex polygon. So notice the big difference here is the other one went in like that. All those dimensions are the same. What's different though is the area on this second figure is greater. What about perimeter? Well, perimeter, we have, instead of having 2 sides, we only have 1 side. And that 1 side will not be longer than those 2 sides together. So for a comparison, the second one has the bigger area. Bigger area. But the one on the left, the first one, has the bigger perimeter. On number 24, find the perimeter of the quadrilateral RSTU in the coordinate plane at the right. So on this one, we're gonna have to break it down into smaller pieces. You're not gonna have one this hard on a test, but I could draw in a horizontal line and a vertical line here and break this into a lot smaller pieces to find the overall area. Now for perimeter, I'm gonna have to use distance formula probably, or Pythagorean theorem. So that's gonna be a little bit harder. But I'm gonna have to stop this video here because it's the start of another class period. So I will finish this one off on the next video. So we'll pick up here. Let me go ahead and stop this and save it, and then I'll do the other video. So if you have anything from 24 on, just go watch the other video.